Yes. Good to go.
Hi guys, so we are Team 3, Team Solar, and then this is our presentation on our project Phytora. So this is just an agenda and a breakdown of everything we are going to cover in this presentation. So starting with the agenda, we move into the team member roles and responsibilities.
And coming to the team members, and this is Manoj Kumar, and I'm the machine learning engineer for the Fedora. I mean, for the project, and I'm taking care of the algorithms and the process going to implement for the AI we are going to implement in the application.
Hi everyone, myself Krishna Kishore Verma. I'm a backend developer for this project.
Hello everyone, I am Gopi Krishna. I am a backend developer for this project. I will be taking care of the backend.
Hello, this is Cyprian Ambudi. I'm a front end lead. I'm taking care of diagrams.
Hi, this is Karthik Potru. I'm a machine learning engineer for this project.
I'm Paul Morales. I will be the front end developer on this project, making sure the web application and the UI is visible and functional.
Hi, my name is Nikita Arpula. I am a backend developer and QA for this project.
Hi, I'm Lakshmi. I'm front-end developer working under Paul.
So moving on to our project description, here we just give a breakdown of what we hope to accomplish with this project, who it's for, and what we hope it will do for the users. So we started off by saying this is mainly for farmer and agriculture researchers, as it does deal with plants and leaves, and those will be our main target audience. And just to create an efficient and cost-effective method to detect these diseases, which in the long run will be beneficial for those in the agriculture field. We built it with an AI-based plant disease detection system that will allow users to have a diagnosis of a leaf just from simply uploading the picture. And our application leverages CNN or convolutional neural networks, and this provides fast and accurate and automated disease classification, as I mentioned before. And we also listed the benefits that will come from this project. They are early detection, so the faster you can detect that there's a disease in the plant, the more likely it is that you are able to save it. Like I mentioned before, it's cost effective, high accuracy because the AI and the deep learning models that we use will minimize misdiagnosis. It's very, very scalable, so with more users, we'll be able to still maintain functionality and very user friendly. So go on to the next slide, please. And we're just going to talk about the improvements. So starting off, the team introduction slides were reordered. So we felt this better fit the flow that we want to accomplish, and it follows a checklist now. Slide titles are standardized, so we added and we fixed any missing titles that we needed to. Content alignment was fixed, so the text matches the slide topic, and the visual and structural cleanup. We just wanted to remove any clutter and make it as simple to understand as possible. And going into the team working agreement. So here we just listed 8 topics that we feel are very important, starting from the purpose and the scope. So you have a good grasp and understanding of what this project is meant to accomplish. Moving into the roles and responsibility, we introduced ourselves a little bit earlier, but just a breakdown of what every developer and member of the team is going to accomplish and work on. Then we go into our sprint planning and our retrospectives. So the sprints are mainly just review achievements, blockers, and process improvements. This is how we make sure that every week we are getting better and the project is getting closer to being ready for production and it's all functional. We go into communication and collaboration. Very important that our meetings take place to make sure that we're all on the same page and we're all working collectively as a team. Moving into the development and the workflow and code management. Here we're using GitHub to make sure that everything is merged and all our code is up to date. So when we do add something, it's reflected for everybody. We go into accountability and conflict resolution. So just making sure that we're dealing with blockers and any issues that we may have efficiently. This also makes sure that we are never delayed and we're hitting all our deadlines, which moves us into our work hours and availability. We've all have set aside allotted time to meet and to work on this project, which is what has made everything a lot more functional and a lot better, and work flexibility to make sure that the tasks align with the sprint goals. And then finally, we finalize it with just an agreement and a commitment to the team and to the project.
Yeah. Coming to the personas, we're having three people. He's a farmer John. He's 45, and his occupation is apple orchard owner in Washington, USA. And he's farming from past 20 years. He's taking care of apple plants. When he's going to grow some apple plants, he faced several issues regarding the diseases he recognized when he planting. Making it over. So after that, he consulted a lot of people to reduce the diseases regarding the red light. Bad light. We have the a lot of kind of diseases affected by the plants. It's nothing but disease management and dependency on expert. I mean, sorry for that. We have several leaf diseases. He's mentioned in the his report. After that, we have another person who is taking care of the research kind of thing for the project. Go to the next slide. And she's Amy, and she's agriculture researcher. She's taking care of the plant disease based on the color, size, and shape. We have several ML techniques as well to take care of. To divide the plant disease by using K-means clustering algorithm, and we have many kind of things. So she is taking care of research about the plants, how it behaves when the weather changes in some winter and all, and she is reporting to the the authority to taking care of the farmers plants, how it going further in every stage. And the next person is the CEO of a smart farming startup, and actually he's having a company. He's taking care of AI based application which helps farmers to get rid of the risk they are facing when they're growing plants and farming things. So he needs a lightweight AI model. So he's actually taking all the data sets accomplished by the ME and the diseases uh, taken care from the person who is from Washington. He's made all these things, and he developed an AI environment by using plant images. After that, he can train the image and he can give the better results by the end of the day. Next slide, please. The minimal viable product is going to be, actually we are going to give the data set, set of images. In that we having all the diseases description and all. It's nothing but AI focused. So when we are going to give the image to the application, it reads the image criteria based on the color, size, and various categories. After that, the disease is going to be detected. After detection of the disease, the AI model used to taken care of the things. Is nothing but the color and the rusty nature of the leaf and all. After that, it gives the minimal 60 to 70% of the pesticide product. After that, it goes to the pathologist. I mean, she is going to taking care of the rest of 40%. The instant diagnosis is taken care by the Amy. That's it from my end.
So, hi everyone. So, I'll be saying about the technologies. So we can, yeah. So in this for this project, we are using few technologies. Like for the front end, we are using Next.js. For the back end, for the Node.js and Fast API. For the machine learning part, we are using PyTorch. For the database, we are using SQL. For the development, we are using Visual Studio. For the version control, we are using the GitHub. For the deployment, we are using Visual. For all this technology, there is like brief explanation for like if you guys need like as for the Next.js, it is used to like for mostly for the web interfaces between the clients for the users to see what they are actually seeing. So we are using Next.js because it's very fast and responsive. As for the backend, we are using Node.js and Fast API because uh, they can efficiently handle the user requests and in the real-time processing. So which will make the whole process of it to get the results quicker. So as for the PyTorch, which is used for machine learning, so it's more accurate. It helps us to learn and to give the accurate disease detection using deep learning models. So for this reason, we are using the PyTorch. But as for the skill, we are storing the image. So we'll need to store the image to train the AI model, right? So we're storing the whole information of the healthy pictures of the healthy leaves or healthy crops or something, and along with the disease plants, to train to train the AI model more, to train the machine learning model. So as for the Visual Studio, which we are using mostly these for the codes and to build the code which we have written. As for the GitHub, we are updating it now commonly so everyone can watch. So Vercel it's used to deploy the front end with using the GitHub for quick updates to see everything. Can you go to the next slide? Yeah. So next I will be going for the algorithms. So for this one, we are using Efficient. So it's an advanced CNN model which gives us accurate and efficient plant disease detection. It is designed to optimize the performance by smartly balancing model depth, width, and image resolution. So it helps us to both fast and give the accurate details. So here, Fast API integrates the model into the backend, enabling real-time predictions with minimal delay. So it also ensures the farmer and researchers give the precise disease detection and identification in early stages, which helps them to make the crop management better. Here, through using transfer learning, the model leverages to pre-training knowledge within the database and gives the accurate with the limited data which he has. That's it from my side. Okay.
Coming to the diagrams, I'm going to explain the diagrams. Like we have architecture, state, context. Coming to the architecture, the architecture diagram. I'm getting double voice. Sorry. The architecture diagram outlines the fundamental structures of a Pythora system. Here, the detailing the interactions between various components as we seen in the image. And the process are begin with the farmer who uploads an image through the Next.js frontend. And this request is sent to the Fast API backend, which acts as a system core processing unit. And this backend forwards the image to the forwards to the image to a PyTorch based machine learning model, and it's responsible for analyzing the image and detecting any plant diseases. And once the model returns the diagnosis, the backend stores the results in the PostgreSQL database for the record keeping in retrieval. Finally, the pre-processed data is sent back to the front end and allowing the farmer to view the results. Finally, the structure workflow ensures the efficient and real-time disease detection process. Next slide. Coming to the context diagram, provides a high-level overview of how the Pythora application interacts with external entities. The primary uses of a system is the farmer who uploads an image of a potential diseased plant, And this image is processed within the Pythora application, which leverages AI to analyze the detector diseases. So once the analysis is completed, the results, including the identified disease and confidence level, those are stored in a PostgreSQL database for future reference. The application is so deployed via Vercel also. So it is making easily accessible to the farmers from any device to the internet connection. So this context diagram effectively illustrates how the data flows within the system and how different components it interacts to the delivery results. Coming to the ER diagram, this ER diagrams represents the data schema of a Pythora system, showing how different entities are structured and connected. And the system consists of multiple and including users, images, diseases, and results as shown in the image. Each farmer is identified as a user, and we are uploading multiple images which are stored in relevant as metadata such as timestamps, image paths. So the disease, and here we are seeing the disease entity contains it's a predefined classifications of plant diseases which the machine learning model reference during the analysis. Once an image is analyzed, the result entity logs the diseases detection outcome along with the confidence score, and the relationships ensure the structure and efficiency data storage. Coming to the sequence diagram. So this sequence diagram showcases step-by-step interaction between different components of a Pythora system during the diseases detection process. The process begins when the farmers uploads an image through the front-end interface, uh, and the front end sends the image to the backend API, which process the request and forward to the AI model for the diseases analysis. So these diagram effectively visualize the end-to-end workflow of disease detection process. Coming to the state diagram, this state, can you change the slide, please? So the state diagram represents the different states and image go through the during processing. First, our process the starts when an image is uploaded by farmer. Once uploaded, the image is pre-processed and ensuring it meets the required format and quality for analysis. The analyzed state is where the AI is evaluating images for this disease detection, and if we found a invalid image, the system flags it's an error. Uh, uh, Once it is uh, stored, and it's not stored in the form in the system. It's not stored in the system. And this diagram helps in understanding the life cycle of image within the system. This that's it. And the class, coming to the class diagram, uh, one second. Here for the former uploads the image to and send it to the packet on once. Okay.
That's okay, Cypri. I will take care of it. Actually,
Um,
here is the methods we are using in the application. These are the method names: upload image and the view results. These are the methods used in the farmer class, and then we have the front end class and back end classes as well. Display upload form and the display results form. These are the methods included in the front end, and backend have the same kind of methods. And here is the AI model class and database class. These are the things used in the rest of the class diagram. Thank you for that.
Yeah, hi everyone. Let me walk you through the product backlog from the Python system. This is essential for our game plan. So in the first sprint, we have primary focused on enabling the farmers to upload images for the disease detections. So we started the featuring the allowing the farmers to upload the images via the desktop or mobile. So these images are stored in the backend, so it will keep everything organized. Once the images was uploaded, the system checks the leaf was healthy or diseased. So this will give the immediate feedback to the farmer. So on the technical side, like, can we go to the next slide, please? On the technical side, we have worked on pre-processing the images to ensure they are clean, noise-free, and resized appreciate the for the AI analysis. So we also set up image logging for the auditing purpose. So we can help that will help to the tracking the issues. And coming to the sprint two, we did like enhancing disease detection. In this sprint, like we leveled up the system capabilities. For example, we have added the functionalities to detect the specific disease like scraps or rust to make the results more transparent. We included the confidence score with the diagnosis, giving the farmers sense of how the reliable results are. Plus, like we started offering the basic recommendations for the treatment, such as suggesting fungides. Like on the technical side, we have a validation to ensure only leaf images to be processed and implemented through API test causes to make system more reliable. Coming to the sprint tree, the performance and usability. Finally, like in the sprint, the goal was to improve the performance and the usability. We introduced the history page, like where the farmers can view posts and upload the track diseases trends over time to the process like more efficient. We added the batch images uploads to the US 3.2, saving more time to the farmers like in managing. Can we go to the next slide? Can the managing the multiple lists, like we focused on the mobile compatibility, enhancing the system runs seamless. Like these are working in the field. For the technical perspective, we optimize the AI model for the faster processing, reducing the detection time to uh, under these 3 seconds per the image. Additionally, we set up AI error logging in the SQL to help developers quickly address any issue. Overall, the product backlog has been instructed in the keeping. We focus the farmers need to be maintained steady technical improvements. It is also balancing functionality, performance, and build something truly impactful. So this is from my end, guys. So now Nikita will take you forward.
Hello everyone. Coming to Sprint Backlog. So the backlog is focused on building the core functionalities of Pythora, and farmers directly they will upload the images of the leaves for the disease dissection, and the system will classify them and it will give whether it is healthy or diseased. To ensure the accuracy, the images are pre-processed and before analysis, the result will be stored in the post GRE SQL, and we can track that result as well. And a CI or CD pipeline is also set up for the automatic deployment to Vercel and the streamlining updates as well. And each task includes the acceptance of criteria and assigned to the story points to track each and every point. Coming to the next slide, for this test cases, and when the user upload the images, it was tested based on the user story one and all, and it checks and based on it was tested and valid or invalid files and disease detection. It was verified with the accuracy as well. And pre-processing database was logging in, and the CI and CD deployment were validated for ensuring the system reliability. Coming to the next slide, user stories. By the end of the sprint one, all planned tasks were completed successfully, and the system now allows the farmers to upload the images directly, and it detects the diseases as well and receive the direct feedback. And images are optimized before analysis, and results were secured based on the logged ins. And the CI and CD pipeline ensure the seamless deployment. With a stable foundation in the place, the system is now ready for the further enhancement for becoming Sprint 2. Yeah, that's it, guys.
Can we move the slide? After metrics. Team velocity. As a team, we successfully completed 80 story points in sprint one. It's strongly demonstrating execution and efficiency. It reflects the steady progress and effective sprint planning. Can you turn the slide? The bundle chart. This basically tracks progress over the sprint. Initially in sprint one, our work was slowed down slightly, but we picked up in the mid by closely planning the bundle rate. The team efficiently completed all tasks within the time frame, sprint time frame. Can you turn the slide? Completed or committed ratio. The team actually achieved all 100% completion rate by delivering all 18 committed stories. This highlights planning, execution, and collaboration throughout the sprint. Can you move the slide? Retrospective. Actually, we did well by doing good understanding of the project and the roles allocation and user stories done perfectly. And we are going to improve some points, basically prioritizing our task activities, long meetings, and there are some action items we are going to follow. Basically, one point I want to follow is conducting risk management to avoid obstacles in the future. Can you move the slide? Sprint to planning. Basically, sprint to planning was basic focus shifts to enhancing the disease detection and reliability. First, if I am taking story as a for farmer, a specific disease identification under ID of UF 2.1, it detects the disease type, exact disease type, example scab and rust. If we are taking confidence score under ID to US 2.2, it displays results reliability. And if as a farmer, if I'm taking treatment advice under ID US 2.3, it provides action recommendations. And non-leaf image validation under ID 2S TS 2.1, it prevents incorrect uploads. Automated testing under ID TS 2.2 adds IPA test coverage for system stability to upload, detect, and classify. Can you turn the side? You can do your project demo, Karthik.
Hello everyone, my name is Kratik. From here on, I am taking over from the project demo. So here is a detailed screenshots about the project we are going to working on. Let me drive you through the website. Here you can see the web framework for our project. Now, here we are in a home page. So if you see here, we can scan the leaf and we have to upload a leaf image, apple leaf image, which is already unhealthy. So here we're gonna press the analyze leaf button. In this process, it's gonna analyze the leaf, what kind of disease it has, and here it described that the leaf is diseased. So yeah, this is all the screenshots regarding to that. And this is the final screenshot. Here it says the leaf is diseased or not. You can put as many as leaf pictures if you want. If you want to keep one more, you have to go to the back, scan again, and you have to upload the images here. You can upload the same image, different image, whatever it is. It will analyze and it will show you the result. Let me refresh it. Yeah, there we go. So here is our wiki page. Here we put everything that we are worked on, our tools, our requirements, our project members, roles and membership and everything. This is the link to the wiki page, Team Solar. And that's it. Thank you.
Thank you, guys. Thank you, Professor.
Thank you, Professor.